Welcome back to RS Academy. This is Ravi Shankar. In this session, let us have a talk regarding to base. Put heading basis. Basis. So we are going to discuss in detail regarding to basis. So what is meant by base? Classification of basis. Properties of basis. So get ready, students. Let us have a talk regarding to basis in detail. So basis. So then what is meant by base? A base is a chemical substance just bitter in taste, bitter taste, turns red litmus to blue, turns red litmus to blue. They have pH greater than 7, that means more than 7, more than 7, pH more than 7. Next, the soapy to touch, soapy to touch, they are slippery in nature, slippery nature. Bases means those chemical substances which has bitter taste, turns red litmus to blue, pH more than 7, the soapy to touch, slippery in nature. So then what is the exact definition regarding to bases? Let us look into that. So bases means those chemical substances which produce OH minus ion when they dropped in water. Produce OH minus ion when they dropped in water. Base means or bases means those chemical substances which are ready to produce OH minus ion when they dropped in water. So listen to me here. This is a symbolic representation of base. BOH, let us assume I am dropping BOH in water. It split up into B plus and OH minus. Right. So BOH, let us assume symbolic representation of base. So when it is dropped in water, it split up into B plus and OH minus. B plus and OH minus. According to chemistry, those chemical substances which are ready to produce OH minus ion when they dropped in water considered as bases. So OH minus ion is called hydroxide ion. Hydroxide ion, also called hydroxyl ion. Hydroxyl ion. Please make a note of it. Hydroxide ion or hydroxyl ion. Now let us have a look some examples. Let us conclude what is meant by base. Bases are generally bitter in taste, soapy to touch, slippery in nature, the pH more than 7, the turns red litmus to blue. Not only that, being a base, they must produce OH minus ion when they drop in water. For example, sodium hydroxide. Sodium hydroxide. Chemical formula NaOH. Sodium hydroxide. Sodium hydroxide when dropped in water, it ready to produce Na plus and OH minus ion. Potassium hydroxide. So let me write the common name of sodium hydroxide as well. Look into that. Sodium hydroxide, also called caustic soda. Based on the common names, you will get the question. Please make a note of it. Sodium hydroxide, formula NaOH. The common name caustic soda. Sodium hydroxide, when dropped in water, you must have seen that it split up into Na plus and OH minus ion. Next one, potassium hydroxide. Potassium hydroxide split up into K plus and OH minus ion. Potassium hydroxide split up into K plus and OH minus ion. So potassium hydroxide also called caustic potash. Caustic potash. Next one, calcium hydroxide, CaOH taken twice. Calcium hydroxide, it split up into Ca2 plus and 2 OH minus ions. Calcium hydroxide, also called slaculine. Please copy these points. Right. Next one, sodium hydroxide, caustic soda, split up into Na plus and OH minus ion. Potassium hydroxide, also called caustic potash, split up into K plus and OH minus ion. Calcium hydroxide, Ca2 plus along with 2 OH minus ions is called calcium hydroxide, also called slaculine. And not only that, please remember one point here, the aqueous solution of slaculine also called lime water. Please make a note of it. Lime water. Okay, right. Next example, magnesium hydroxide. MgOH taken twice, it split up into Mg2 plus and 2 OH minus ions. Mg2 plus and 2 OH minus ion is called magnesium hydroxide. Also called milk of magnesia. Very important, milk of magnesia, which is used as antacid. Very important, antacid. Antacid means opposite to acid, that is a base, is a mild base. So that's why it is used to neutralize the excess acid inside of the stomach. To neutralize the excess acid in the stomach. So antacid. Next one, ammonium hydroxide. NH4OH, ammonium hydroxide, split up into NH4 plus ammonium ion along with OH minus ion. So ammonium hydroxide, just remember. Next one, aluminum hydroxide, AlOH taken thrice, it split up into Al3 plus and 3 OH minus ions. Aluminum hydroxide, ammonium hydroxide, magnesium hydroxide, calcium hydroxide, potassium hydroxide, sodium hydroxide are generally considered as bases because of they are ready to produce OH minus ions when they dropped in water. So not only that, generally metal oxides are basic in nature. Please make a note of it. Bases generally, metal hydroxides are bases. Sodium hydroxide, magnesium hydroxide, calcium hydroxide, these are basic in nature because of they produce OH minus ions when they dropped in water. Not only that, magnesium oxide also considered as bases. Please make a note of it. Generally, metal oxide. Generally, Metal oxides also considered as bases. Metal carbonates, generally metal carbonates are basic in nature. Metal bicarbonates also basic in nature. Let me give example for this one. So metal hydroxide examples, magnesium hydroxide we can use. So magnesium hydroxide, potassium hydroxide, calcium hydroxide, aluminum hydroxide, these are generally bases. So metal oxide, sodium oxide, magnesium oxide, calcium oxide, generally these are basic in nature. Metal carbonates also basic in nature. Example, sodium carbonate. Next one, sodium carbonate, potassium carbonate. These are basic in nature. Potassium carbonate. Next, generally metal carbonates, metal bicarbonates also basic in nature. Example, baking soda. Baking soda. So baking soda also used as antacid. Please remember this. Milk of magnesium used as antacid. Milk of magnesium used as antacid. Alright. Baking soda also used as antacid. Generally, metal hydroxides, metal oxides, metal carbonates, metal bicarbonates act as bases. Please keep these points in your mind. Right? So this is what is meant by base and their examples.
Properties of bases. Properties of bases. Physical property. Generally, bases are better in taste, soapy to touch, slippery in nature. They turn red it must to blue. They must have pH more than 7. Not only that, bases are good electrolytes. They can conduct electricity in the form of the aqueous solution. So now let us move on to chemical properties of bases. These are very important. Based on chemical properties of bases, you will get the question in the examination. So there we have only three chemical properties according to our syllabus. That is bases with, make a note of it, bases with metals. Bases react with metals, give salt plus hydrogen gas. Bases react with acids, gives salt plus water. Bases react with non-metal oxide, gives salt plus water. Please make a note of it. This is the flow chart regarding to chemical properties of bases. So now let us discuss these chemical properties in detail one by one. Bases with metals. So let us start bases with metals. Bases with metals. Generally, bases react with metals, give salt plus hydrogen on heating, not at room temperature. Generally, acid react base with salt and hydrogen gas at room temperature, but in case of bases, we need to provide heat energy. On heating, we will get hydrogen gas. So when bases react with metals, so take few ml of aqueous solution of caustic soda as shown in the figure. Take few ml of aqueous solution of caustic soda for the sodium hydroxide. Caustic soda, sodium hydroxide, chemical for the NaOH. And add few zinc granules to it. Few zinc granules. Few zinc granules to the caustic soda and start heating above the flame. So on heating, you must have seen that evolution of hydrogen gas taking place. Evolution of hydrogen gas taking. If you want to check the nature of this gas, bring one burning candle or matchsticks and burn with pop sound. Burning with pop sound is a characteristic of hydrogen gas. Now let us write equation for this one. So zinc granules react with sodium hydroxide. You will get sodium zincate, Na2ZnO2 along with hydrogen gas. Sodium zincate. Only four combinations you will get regarding to metals with bases. One is zinc with sodium hydroxide, zinc with potassium hydroxide, aluminum with sodium hydroxide, aluminum with potassium hydroxide. Only four combinations you will get in case of bases with metals. So I will write on the board, please copy the combinations. In case of metals with bases, you will get a question based on four combinations. One is zinc with sodium hydroxide or potassium hydroxide. In this combination, remember zinc cations. ZnO2 2 minus ion. Please remember zinc cation. It helps you while writing equations. Next combination, aluminum with sodium hydroxide, aluminum with potassium hydroxide. For this combination, remember aluminate ion AlO2 minus. Not only that, for writing equation, the reaction between aluminum with bases, we need to add water molecule in the side of reactants in order to balance the chemical equation. So please remember these all the points. They help you while writing equations regarding to metals with bases. Only you will get four combinations, that is zinc with sodium hydroxide, zinc with potassium hydroxide, two combinations, aluminum with sodium hydroxide, aluminum with potassium hydroxide. So in case of zinc with bases, remember zinc cation. In case of aluminum with bases, remember aluminate ion. So not only that, we need to add water to the side of the reactants. Now let us write equations for this one. Zinc with sodium hydroxide, we get sodium zincate Na2ZnO2 plus hydrogen. The next one, zinc with sodium hydroxide, you will get potassium hydroxide, you will get potassium zincate K2ZnO2 and hydrogen gas. In case of aluminum, aluminum with sodium hydroxide, I said we need to add water molecule to balance the equation. We will get sodium aluminate NaAlO2 along with hydrogen gas. Next one, aluminum with potassium hydroxide. We need to add water in the reactant side, and you will get potassium aluminate KAlO2 along with hydrogen gas. So we get four combination: zinc with sodium hydroxide, zinc with potassium hydroxide, aluminum with sodium hydroxide, aluminum with potassium hydroxide. But only two metals ready to react with bases, that is zinc and aluminum, because of these are amphoteric metals. Amphoteric metals means those metals ready to react with acid as well as base. So these are called amphoteric metals. Only amphoteric metals are ready to react with base as well as acids. Here zinc and aluminum both are amphoteric metals. Write down zinc and aluminum. These are amphoteric metals. Amphoteric metals. So remember these four combinations regarding to metals with bases. Okay, copy this. Next one, acid with bases. Generally, acid react with base gives salt and water, and base react with acid gives salt and water. Both are same, but this is called neutralization reaction. We have done this in case of chapter number 1, chemical reaction and equation, and in this chapter also, that is second chapter, in case of chemical reaction, chemical properties of acids. But here I would like to give few examples regarding to reactions between acid and bases. Put it in. Bases react with acid gives salt plus water. This is called neutralization reaction. Neutralization reaction, also called double displacement, double displacement reactions. Generally, these are exothermic in nature, and these are not a redox reaction. Not a redox reaction. Please keep this point in your mind. Not a redox reaction. Generally, double displacement reactions are not a redox reaction. So the reaction between acid and base is a neutralization reaction, double displacement reaction. Generally, neutralization reactions are exothermic in nature. These are not a redox reaction. Example: sodium hydroxide react with hydrochloric acid, you will get sodium chloride along with water. Potassium hydroxide react with sulfuric acid, you will get potassium sulfate along with water molecule. Next, calcium hydroxide react with nitric acid, you will get calcium nitrate along with water molecules. Right? So the reaction between bases and acids are considered as neutralization reaction. Is it clear to you? Okay, next one. Bases with non-metal oxides. Bases with non-metal oxides. Generally, bases react with non-metal oxide gives salt and water. That means here non-metal oxides are acidic in nature. Please make a note of it. Generally, non-metals react with oxygen gives non-metal oxides. Non-metal oxides are acidic in nature. Acidic in nature. Generally. Example: carbon dioxide is a non-metal oxide. Sulfur dioxide is a non-metal oxide. Nitrogen dioxide also non-metal oxide, which are acidic in nature. Generally, non-metal oxides are acidic in nature. But some non-metal oxides are neutral in nature. Example: water is a non-metal oxide which is neutral in nature. Nitrous oxide, laughing gas, is neutral in nature. Carbon monoxide, neutral in nature. And nitric oxide, neutral in nature. Generally, non-metal oxides are acidic in nature, but some non-metal oxides are neutral in nature. Being acidic in nature, they are ready to react with bases. So that's why you will get salt and water. Generally, bases react with non-metal oxides, give salt plus water. So what is the reason behind that? Generally, non-metal oxides are acidic in nature. So that's why they are ready to react with bases and produce salt and water. Example: carbon dioxide when passed through the lime water, you will get calcium carbonate along with water. Here calcium carbonate is a salt, so water is the base, it must be a acid. That means non-metal oxides are acidic in nature.